So, to hopefully give you more time in class, you get to listen to this solids, liquids, and gases information, and then we'll do some of the things that it says in class later this week. So, the key thing here is that you're paying careful attention to how the microscopic properties inform the macroscopic properties, so the way that we experience the different states of matter in our everyday life. We are just looking at the main three, solids, liquids, and gases. Those aren't the only states of matter, but they are certainly the ones that we interact with on a regular basis. So, here we go. So just reminders, macroscopic is sort of looking at the big picture, the way that we see things with our eyes regularly. Microscopic means you're looking on a small scale, sort of often I call this like magic school bus. You shrink down very small and see what things look like on the atomic level or the molecular level. So even a little smaller than we were looking at last year in biology. The key thing throughout all of this, and really through chemistry, much as it was in biology, is to pay attention to the fact that the just like structure determined function last year, now microscopic informs the macroscopic. So the way things are actually bonded together atomically or arranged on an atomic level informs how they behave and the way we experience them. So we're going to go through each of the three states macroscopically, because that's what we know, and then we'll look at how they are microscopically to make them look that way. So solids macroscopically, kind of think about some solids that you're familiar with, look around you. Solids are unique because they have a constant volume and a constant shape. They kind of are what they are. They don't spread out or shrink down or whatnot to take the shape of their container. They also tend to have a relatively high, constant density. So you can't squish them into a smaller amount of space and increase the density. Liquids also have a constant volume, which is how you could measure the volume of a liquid in a graduated cylinder or beaker, what have you. They don't have a constant shape, which is why you can, take a drink from your water bottle. The water fills up your mouth and then can go down into your stomach. So you can change shape depending on the container, but always keeping the same volume no matter what you're measuring it in. Their densities tend to be a little bit lower than a solid, not always true, but they do change volume very little, similar to a solid. So they're not going to spread out a lot or get smushed, get compacted a lot either. So they're going to stay relatively the same density and the same volume all the time. Gases, on the other hand, are basically the opposite of solids. They tend to have fairly low densities. They're definitely not constant. A gas can spread out throughout a whole room or, shrink down into a small balloon or something. Gases don't have a constant volume, so they can, again, fill up any container. If you've ever been to like a movie theater or another enclosed sort of space where someone's wearing a lot of perfume, soon the perfume will fill the whole space and you'll be able to smell it all throughout the area. They also don't have a constant shape, so again, they're spreading out to fill up the whole container, whether it's a balloon or your lungs or a room. You can really spread out a lot. So here is just a little summary. This is on not Schoology as well, so you can do with this what you will. So, microscopically, why do solids have a definite shape, have a definite volume, have a definite density? In a solid, the atoms and molecules are bonded together. They're actually chemically attached to one another. So they cannot move independently of one another. If one part of the solid moves, the whole part of the solid moves. That's not to say that they don't move. They certainly sort of move around at their spot. You can think of it like in class, sitting at your desk. Every student is in their own position. They're sort of locked in place in their desk. However, at that desk, they can move around in that place. So they're kind of vibrating, the solids, kind of vibrating in their spot, but not moving independently. So because of that, they're stuck. So one part of the solid can't change without changing the whole thing. And we'll do the demo in class Thursday, Wednesday, in class. Liquids, microscopically, have atoms or molecules that are not bonded together. However, they are still attracted to each other. So if you think back to biology class, you talked about hydrogen bonding a fair bit with water. So molecules in water, they are attracted to each other because of the opposite charges. So they're still kind of in contact with one another, but those attractions can switch and flip and change around all the time. So water can change shape, it can flow, you can pour it, but because the molecules are still always in contact with one another, you're not really able to squish it down any further. Finally, gases. Here, the atoms and molecules are not bonded together. They're not really attracted to each other. They're really zooming as fast as they can, all around, all the time, wherever they want, within the confines of their container. So they tend to be very far apart. Again, they're moving very quickly, and so they can fill up a very big space, or you can shove them much closer together and put them into a very small space. So because of that, they can fill a room, they can get into all the little nooks and crannies of a particular shape, and really spread out a lot. So again, we'll do the demo of these different properties on Wednesday. You will also watch the movie in class on Wednesday. And this is just a little reminder. Solids are bonded, not moving. Liquids are free to move, but they're still attracted. So they're still coming into contact with each other, moving relatively slowly. And gases are zooming everywhere all the time, very fast.